Phuket World is a channel that, surprisingly, has nothing to do with Thailand. He is, in fact, a flat earther, among other conspiracies as well. And today, he thinks he's figured out a flat earth map that actually works. And I must concede, I think he may be onto something here. You'll see what I mean. Enjoy.
Hello, Flat Earth researchers, debaters, and debunkers.
Oh, I'm one of those. Guess which one?
When those who believe in the globe cannot replicate or demonstrate any kind of measurable proof that we live on a spherical spinning Earth with any kind of real physics.
It might have something to do with, I don't know, maybe it not needing a belief. Also, most people simply don't care enough to look it up. You also don't get to use the word physics, since you have no idea what it means. Sorry for the interruption. Do continue.
The last resort is to demand a working flat Earth map.
Actually, that's our first question, not our last resort. We have never even come close to needing a last resort.
And so that's what we have here. We're going to see how you can make flight plans across a flat Earth map.
I don't think anyone has ever said that you can't make flight plans across the flat Earth map. They simply just don't reflect reality.
And all I've done is taken it from this illustration of the northern and southern hemispheres. It's the 1838 Bradford map of the world.
Oh, that is going to make a great thumbnail.
With two polar projections, the northern and southern hemisphere. Okay, northern over here, southern over here. This map on here is the other way around. I've got the north here and the south pole here. So before we get into this, let's really try and clear up what is actually happening when we look at a map like this.
What needs clearing up? It's quite simple, really. One is looking at one pole and the other is looking at the other pole. I don't need a 20-minute video to explain that.
Of course, we've got these two hemispheres, so these are two central azimuth points.
Here is a Google Earth representation of the same thing, kinda. I'm not very good at Photoshop. It doesn't show anywhere near as much detail regarding land masses, but that's to be expected, since I'm not that good at using Google Earth either.
So they have been assumed, and of course we have the North Pole and then the South Pole, which of course on a globe, these are supposed to be opposite points.
You'll notice that it seems to be missing Antarctica, and they are opposites. But go ahead and dazzle us with your revelation.
Which is a fallacy in the first place, because a globe doesn't have a top or a bottom.
Only an idiot would think that these represent the top or bottom of anything. Do you not know what the poles actually represent?
Yet we have been given a globe with a top and a bottom, and that's simply because what we have here is two azimuth maps, and of course what we can do is sandwich them together.
Oh dear. You're not really going to do this, are you?
Like this, for example. And if we did some origami and cut along the lines to make segments, then we would end up with a globe.
No, you wouldn't. You'd end up with a mess. A circle is not half a sphere. If these slices represent anything, it would be more the form of a cross-section, with the land projected onto it, rather than showing the layers of the planet. It's not that, but it's the closest representation. This image shows what I'm talking about.
At the moment we've got a kind of two-dimensional disc, okay, but you can see how we would get a globe from these two azimuth projections. All right. So on this one that was illustrated, they join up here with South America. So I'll just put that there. Okay. It's kind of how it came out, and then I cut out the circles. Okay, so of course, if this is a globe, then we have this cutout being around the equator.
This is something 5-year-olds do in school. You also keep mentioning how it's an azimuth projection, which means you're either parroting where you got it from, or you do indeed know what a projection is. I'm hoping it's the former, otherwise you're being incredibly dishonest.
But what do we actually have? We have just two azimuth points. So let's take the North Pole to start with. And this, of course, is what's often used as a flat Earth map projection. And it then goes as far as including all of this on the outside. And it gets wider and wider. And of course, it seems that we could have an ice wall around us. But that's just a visual representation because we've only got between north and south to go to.
Are you implying there is more than just north and south? I really think you don't understand what the poles actually represent. Technically, there are 4 poles: magnetic north and south, and true north and south. The true north and south are what these maps are based upon, and represent the axis that the Earth rotates around over the course of a day. Magnetic north and south are what compasses use to make that little arrow point in the direction of north. Although these points move, the motion is insignificant when using them for navigation.
So of course, the further away something is from the center of any given point that you decide is the center, then it is going to, on a map, take up a wider and wider and wider surface area.
So you know a map like this is not representing reality then? Your argument is falling apart in front of your eyes and you can see it. How will you attempt to recover from this?
Because actually in our field of view, the land masses in the distance get smaller and smaller and smaller. So we see more land in a smaller visual space. So that is kind of mirrored in a map.
That, ladies and gentlemen, is what we call word salad. Throw in a bunch of words, hope no one notices, and hope that it all makes sense. Well, it doesn't. Why would a map show the total opposite of what we see? Would make it pretty hard to use a map for anything other than a wall decoration. It was a good attempt though. Let's continue seeing you make a fool out of yourself.
That starts with a center point, and from that center point you've got these increasing degrees. Well, the degrees remain the same, but of course the distance makes it appear wider and wider. So that's just an anomaly of this interpretation of an observation, because of course what's happening wherever you decide your center to be, and you can do this with a website called Azimuth Anywhere. I'll try and put a link in the description. I've showed it before, but you can basically move the azimuth point around the map and basically choose anywhere to be your azimuth.
I think he just likes saying azimuth and doesn't actually understand what it means, and that it actually needs a sphere to have that meaning. I'm just saying.
So you can in fact choose, for example, the center of Africa or Egypt or something as your azimuth center.
Ha! See? I knew he liked saying it. Azimuth. Kinda rolls off the tongue, doesn't it? Azimuth. Sorry, kind of off topic there. I've already forgotten what he was making this video for. Let's speed things along a little bit.
Central point. In the way it's lined up at the moment, we can easily see that we can go from the northern hemisphere to the southern hemisphere. So
Oh no. You are not going to do what I think you're going to do, are you? You're going to imply that the flat Earth is two discs or something stupid like that, aren't you?
If, for example, we were planning a flight from, let's say, the UK, and we were going down to South America, we would just take this straight path, yeah?
Here's a map showing a flight from England to Chile. Not a straight line, even on this map, but it does follow a very similar path. Can you guess why?
And then we would think about, well, okay, what if we wanted to go down to Africa? Well, our map for that particular trip or journey would then be like this. So it joins together. There's the UK, and down we go towards Africa.
Here's another map showing that flight from London to Cape Town, which, again, it isn't perfectly straight, but it does cover the same land masses. Have you figured out why your model there and the real model both work?
So Antarctica, in this case, remains a continent or a country, as it were. But what's also got to be pointed out is that this looks very small on here, and these, of course, around the perimeter, Australia, South America, South Africa, they all look quite large, but comparatively, they will all, the closer they are, then the more they'll squeeze in together and be more or less similar sizes.
Maybe. Or it could be that this map is from 1838 and Antarctica hadn't been properly mapped out at that time. Antarctica is 14 million square kilometres. For perspective, Australia is roughly half that, at just under 7.7 million. In other words, it's bloody huge.
So that's the thing with the equator, or what is, dividing the two hemispheres on a map, whether you want to convert that into a globe or keep it as two flat maps. That's all we have here is two azimuth maps, which are interchangeable.
No, they're not. On a flat Earth, none of what you have just shown is possible, unless there are two discs grinding against each other whenever someone steps on a plane.
And, so again, north and south outside of the map means absolutely nothing.
Look, this goes on for another 12 and a half minutes, but I think we can comfortably say this argument has been utterly destroyed and just doesn't work on a flat Earth model of this sort. Nice job proving the globe though. If you feel compelled to watch the rest, links to it and all the sources used are in the description below. Now, I highly doubt any flat earthers have made it this far, but if you have, I welcome you to come join the Discord server, where we will hold an open and civil debate. Everyone is welcome. Thank you all so much for watching. As always, a special thanks to Purple Haze and Ghostface for their support, as well as all other patrons. You can show your support by simply liking, sharing, subscribing, commenting, and all that other stuff. And until next time, friends, don't be a dick. Good night.